Hello, we are the Cryptos group, and in this lab we are going to test the vulnerabilities of RC4 and WEP. First of all, we are going to set up the scenario we need to achieve it. We will have two computers. In the first one, we have to put a fixed IP. As we can see in the next image, we have selected this IP for the first computer. And then we have to fix and maintain a ping to the access point in order to inject traffic constantly with the next command, ping -t and the IP of the access point. In the second computer, we only have to install AirCrack software. AirCrack is a tool which implements the attack to recover the web key from the obtained initialization vector. By default, it uses PTW and correct attacks. The PTW attack was released in 2007 and it's more powerful than others because it reduces the number of initialization vectors needed to recover the web key. Instead of trying all possible combinations of key, only picks a number of likely keys and continues the RC4 algorithm based on those. It is able to achieve the 97% of success using only 70,000 packets. On the other hand, the correct attack can decrypt a web data packet without knowing the key, because it does not recover the web key itself, but reveals the plain text. It requires at least one web data packet, but some access points are not vulnerable to this attack. Answering the first question, why do some wireless cards allow to break the web protocol and others not? That's because there are some wireless cards that cannot be set to monitor mode, which means that they cannot scan all the traffic on the network, just can scan the traffic traversing itself. So these kind of cards cannot catch web data packets of the network in order to recover the web key. Referring to the second question, if we know the channel information used to attack the network card, we can speed up the collection of initialization vectors, because we can inject more traffic in that exactly channel and sniff more packets, in order to have more initialization vectors and obtain more quickly the web key.
Hello, my name is Ivan Lago, and this is the part of the lab that I have to do it. Basically is the attack to the access point in order to crack its password. And since we did it in the laboratory, well, in this case I am gonna explain it with the captures. So the first point is the question number 3, that says, to begin with, put the USB Wi-Fi in monitor mode, explaining commands that are used. What is the name of the new interface? So first of all, we have to compare the kind of interface that we have, in this case wireless LAN 3, and we have to set it to promiscuous mode with this command ifconfig wlan3 promisc. And if we improve it, we have this interface set with promisc kind that allows us to capture the whole traffic over this interface. After that, the next step is stop the service airmon ng and start it again, and we see that we enabled the monitor mode in this interface. So if we start again with we put again this airmon ng command, we see that we have these both interfaces. That the one that we want to use is this one, the mon 0. Okay, question number 4 is figure out the meaning of the command aerodump ng and use it correctly to perform a frequency scan. Explain the obtained result. Okay, this command is used in order to capture wireless packets, and is very useful in order to achieve a lot of injection vectors. So with these vectors, we can realize an attack to the web protocol with AirCrack ng in order to get this its key, its password. Okay, so IWconfig shows the interfaces and its frequencies, and IW lists all the frequencies with the interface that has assigned each of them. So this is the capture. Okay, and as I said, we have list every interface with the frequency that it is. Okay, in this case, the Mon0 use frequency 2.4 approximately gigahertz. Okay, the next one, AeroDAP-NG, with the interface that we want, shows every network that uses this Wi-Fi adapter and its powers of the channel. In this case, we see that the best. Okay, so first of all, the best channel that the best channel, actually not the best network that we can achieve is the one with the biggest power. In this case, is minus 43 is the best one. That of course is a network from the access point. This Linksys is its name, and uses the channel number 6. This is the beacons, the number of the data packets received, and the encryption methods, the cipher, and the authentication. Okay, next one is point number 5. Capture injection vectors in order to break WEP, this protocol later on. Okay, we have to use this command, aerodump-ng, channel number 6. The number is the MAC associated to the access point. Now we want the output, the data in this file, this feature output through the interface Mon0. Okay, an output is something like this one with the MAC, the power received of the channel, the beacons, the data packets that we are receiving from this interface, the encryption method, the ciphers, and so on. Okay, if the next question is what happens if we increase the number of concurrent pings, and what happens in fact with this computer, with the computer number 2. If we open the terminals, okay, and we execute concurrent password pings, we can see that the pings goes from 31 milliseconds or 29 as an average delay to the 700 milliseconds of the ping. Okay, so it means that if we execute a lot of concurrent ping terminals, this time of the ping grows a lot. And of course, if there are a lot of pings executing, we also have a lot of packets. In other words, the speed of the received data packets is higher if we grow the pings. Okay. The question number 7 says that we have to copy the capture once we have 10,000 packets and where it has been saved. Okay, the output is something like this one. At this moment we had 10,363 packets, and it's saved in the file that we said before. If we remember, we put feature this / output. Okay, next step is to use aircrack-ng to figure out the key of the protocol that the network is using. Another question is how many injection vectors have been obtained. Okay, we have with the method PTW, we can get the key very fast if we compare with correct method, but this method PTW just works with ARP packets. The command that we have to use is this one, aircrack-ng -b, this MAC, and this kind of output. Okay, and this star.cap. Okay, what means this command? The -b is in order to specify the access point that we are interested in. So this is optional because before we have said that I kind of filtered in order to capture just the data of this access point. So this would be optional in this case. And finally, this output star.cap is in order to select all the files that starts with output and that and end with .cap. Okay, so if we see this output, we can see that we could decrypt the password with 10,000 injection vectors. The main point is that if we have more injection vectors, we can decrypt it faster. The last point is a number 9, and that says repeat the last two steps with 100,000 packets. Okay, the thing is that we had no time to do it, and it's pretty obvious because we just had maybe 4 minutes or something like that in order to do it. But well, we tried and we get 23,000 injection vectors. Well, we see that we well, maybe the time was 1 second as before, because we had enough injection vectors before. So actually there is no relevant difference of the time, but the main thing is that I said before that if we have a great number of injection vectors, it would be easy to do this crack of the password. And this is all about my part. So thank you.
Hello, my name is Daniel Pons, and in this video I'm going to answer the question 10, 11 and 12 of the last lab. To perform these three questions, I have deployed a wireless network with ESSID, the cryptos, with WEP encryption and MAC filtering. So let's start. Number 10. Is there any way so that the non-authenticated user can communicate with the access point? Here we are assuming that the access point has WEP encryption and also MAC filtering. So our answer is yes. We have seen in other lab that it's very easy to spoof a MAC address to cheat an access point. The problem in this scenario is that we don't know what is the MAC address of a client that have their access allowed. So first of all, we're going to check if this network has a MAC filtering enabled or not. To do so, we can use AirPlay trying to establish an association with a fake MAC. Before this, let's analyze the target network with aerodump to obtain some information of the network. So executing aerodump ng. So we can see a lot of networks, but our target has this BSSID and this the cryptos here. I'm going to stop it. So this is the BSSID of our target network. Let's analyze more accurate filtering by channel number 3. Okay, so this is the BSSID of our target, so I'm going to copy it. So with this information we can check if the MAC filtering is enabled or not. So executing a replay ng 10, the MAC address of the access point and a fake MAC, for example this. So we have obtained an authentication error due to this access point has MAC filtering. So let's back again to aerodump. Here we can see aerodump has two parts. First, the networks, and on the bottom the stations associated to some network. With this we can obtain the MAC address that is allowed in a network. So filtering again by channel 3, at some point we will see a user associated with the cryptos network. So if we wait some seconds, here we got a channel correction. We got a client that is associated to the cryptos network. So let's try to authenticate again with this MAC. So now it works. We had association successful. So we know with this that the access point is filtering by MAC, and this MAC is on the whitelist. So clear the screen. So now questions 11 and 12. So if there is no traffic, we cannot capture packet from the access point. How can we force the access point to send data packets to the network? So if there isn't any client, the only way to force some packets exchange between the access point and a possible client is trying to authenticate against. During the web association, authentication association, there is some handshake through the network, and these packets can be captured. This is a slow process, but is possible. So let's try to do the attack. First, we're going to capture packets from the Decryptos network using irodump ng channel 3 to the output file with the BB ID I don't remember. This So as we can see, there is no station, so for this reason 0 packets. So let's associate our computer as a network using a fake authentication. So let's execute airplay ng 1 0. Here the target. I need here the client. So now the number of packets is 0 due to there is no change of traffic. If we continue trying to make the association, at some point the number of packets will increase, but very slow. So there is a technique to inject traffic called fragmentation attack. With this, we can inject packets to a network as a legitimate user. The problem is that our wireless chipset cannot inject traffic. So with this hardware, our only solution is wait for a real client. So that's all. Thank you very much, and bye bye.